Hey y'all, welcome to 9.2. We finna learn some math today. We're simplifying radical expressions. Let's get to this work. Who is this man?
Okay, that's quite the intro to this video. Here we go. Today we're simplifying radicals. You're going to want to have on your paper your perfect squares. So let's write down our perfect squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. When we simplify radicals, particularly square roots, you want to split the square root of 45 into the square root of something times the square root of something else. The first thing should really be a perfect square. So how can we split up 45 using the numbers over there on the left? 9 and 5. The square root of 9 is 3. So this is 3 times the square root of 5. If you have one square root with division inside, you can split this up into the square root of 16 over the square root of 25. So you would have 4/5. This slide has like technical information about how to simplify radicals. Honestly, let's just try it with the examples. I think we'll get there pretty well. Okay, square root of 144x squared. We can split this into the square root of 144 times the square root of x squared. The square root of 144 is 12, and the square root of x squared is x. So our answer is 12x. Okay, square root of 8, x to the third. First, let's talk about the square root of 8. How can we break up the square root of 8 using those perfect squares? The square root of 4, square root of 2, and the square root of 4 is 2. So we have 2 times the square root of 2. Now let's talk about x to the third. We could split this up into the square root of x squared times the square root of x. The square root of x squared is x. So we have x times the square root of x. Now here's the thing. If it's just something like x to the third, splitting it up like this doesn't take too long. But what if it was something like y to the 7th or x to the 10th? That would be a lot of things to write out. So we need to think about some shortcuts. This is a square root. That means groups of 2. How many groups of 2 are there in 3? There's one group of 2, that would be the x, with one left over, that's the one that's still stuck under the radical. We need to clean up this answer. You always start with the stuff that is not under a radical, and you do numbers and then letters in alphabetical order. So 2x, then you write your radical, and then you put the stuff that is still stuck under the radical, 2x. So stuff not under the radical, stuff under the radical. Okay, square root of 18y to the 7th over x to the 10th. Let's start with the square root of 18. What perfect square could we split 18 into?
9.
Square root of 9 times square root of 2. So we are going to have 3 times the square root of 2 instead of the square root of 18. Okay, let's talk about the square root of y to the 7th. How many groups of 2 are there in 7? There are 3 groups, so that would be y to the third, and there would be 1 left over. I don't know about you, but I'm a visual person. So I tend to do something like I make dots. 1, 2, 3, 4, 5, 6, 7. So then I can visually see there's my 3 groups that become y to the third. And there's that 1 that's still stuck under the radical. It just helps me with my kind of Dory brain to not forget things. On the bottom, square root of x to the 10th. How many groups of 2 are there in 10? 5. So x to the 5th. Now we just need to clean up this answer. 3 y to the third square root of 2y over x to the fifth. In example 2, the first thing that we need to do is simplify the square root of 120. 120 isn't quite as easy to simplify as some of the other numbers we've had. You want to get the largest perfect square you can. Half of 120 is around 60, so I would start by trying 49. 120 divided by 49 is a decimal. 120 divided by 36 is a decimal. 120 divided by 25 is a decimal. 120 divided by 16 is a decimal. 120 divided by 9 is a decimal. And at this point, you're probably screaming in frustration. But 120 divided by 4 is 30. So we have 2 times the square root of 30. Square root of x to the 8th. How many groups of 2 are in 8? 4, with none left over. Okay, y to the 5th. How many groups of 2 are in 5? 2, that'd be 4 of them, with 1 left over. On your own, see if you can rearrange that into a nice, pretty mathematical answer. Make sure when you're writing these that your exponents look like exponents. Maybe leave a little bit of a space in between that exponent and the radical. And if you do have to write an index in there, make sure it's really tucked into the checkmarky part so that it doesn't look like an exponent. Number 2, now we're looking at cube roots, which means we need a list of perfect cubes to help us simplify. The perfect cubes that you will probably need are 1, 8, 27, 64, and then I think 125 and 216. I don't think you'd need any larger than that. All right, so the cube root of 54. We want to split this into the cube root of something from this chart times the cube root of something else. 27 times 2. 27 is the third number down, so the cube root of 27 is 3. We have 3 times the cube root of 2. When we simplify the variables, we now have to think about, we're looking for groups of 3 because this is a cube root. So a cube root of x cubed would become x. How many groups of 3 are there in 5? 1 group, and there would be 2 left over. This is when I really like to start using the dots. There's 1, 2, 3, 4, 5. There's 1 group of 3 that becomes the x, and there's 2 that don't get to simplify. They're stuck under the radical. Y to the 9th. How many groups of 3 are there in 9? 3. So our final answer is 3x y to the 3rd. When you write the third root, make sure that your index is nicely tucked into that checkmarky part so that it doesn't look like another exponent. 2x squared. Okay, number 3 looks more complicated, but it's really not. I want you to try number 3 on your own. Pause the video, try number 3 on your own. We can split up 40 using 8 and 5. So we have 2 times the cube root of 5. For x to the 8th, 1, 2, 3, 4, 5, 6, 7, 8. There's 2 full groups, so that's x squared. And then we still have 2 left under the radical. The cube root of w to the 3rd is simply w. To make our answer look pretty, it should be 2x squared times the 3rd root of 5x squared over w. I would like you to try number 1 and number 3 on your own. Notice on number 1, this time it's a 4th root, so you need groups of 4. So try 1, try 3. We are going to change example 2 because that example is kind of terrible and we're going to do a slightly better version of that example. So pause the video, give it a try on your own. On number 3, a very common thing to do is to split up 80 using 4 and 20, which is great. We have 2 times the square root of 20. The problem is the square root of 20 still has a perfect square in it. You can split that into 4 times 5. So we end up with 4 times the square root of 5. If we had split it into the square root of 16 times the square root of 5, we would have gotten to that a little bit faster. So anytime 4 works, it's a good idea to check to see if 16 works because it might save you some time. So the square root of 80 becomes 4 times the square root of 5. And how many times does 2 go into 30? So we have x to the 15th. Our final answer is 4x to the 15th times the square root of 5. Okay, I made a revised number 2. The square root of 2, there's nothing on the perfect chart smaller than the square root of 2, so it's going to stay the square root of 2. How many groups of 2 are there in p to the 11th? 5 of them, with 1 left over. And on the bottom, we can't simplify the square root of 5. The square root of 5 is still going to be the square root of 5. Do any of you remember the rule from Algebra 2 where you can't have a radical on the bottom? Yes. So when that happens, you need to multiply the top and the bottom by that square root. The square root of 5 divided by the square root of 5 is 1. You're really just multiplying the fraction times 1. It's just a fancy version of 1. What happens is, on the top, we have p to the 5th, square root of 2 times 5 is 10, and there's a p. On the bottom, what is the square root of 5 times the square root of 5? Square root of 25, which is 5. Anytime you have a pair of the same square roots, it's basically the square root of 5 squared, so it's just 5. It cancels out that square root. And here's your assignment.